Here we are, AP Biology. This is chapter 25. We're going to be focusing on maintaining homeostasis and the control of the internal environment. This first video is dedicated entirely to thermoregulation, so controlling that body temperature. So oftentimes when we think about examples of kind of the ultimate sleeping arrangement, we think of bears, right? So bears go into a hibernation, and what we often go is, okay, bears eat a whole bunch in the springtime, and then they climb into a little cave, and then they fall asleep, and they stay there until springtime shows up again, thus avoiding the food shortage that often happens in the snow. Well, it turns out that when we look at hibernation a little bit more closely, what we find is that the hibernation is actually a way for us to control kind of the slight factors that might be occurring in the outside environment. And mainly, it's a type of thermoregulation. It's a type of maintenance that happens where we're controlling the body temperature within this little range of kind of this ideal range of temperatures, so that the bear's body will still function when it does gear up to go. Now, there are two different types of animals. There are ectothermic, which means that these animals get their heat and their body temperature is dependent upon the outside or the environmental temperature. So ectothermic animals are only able to control their body temperature by their surroundings. Whereas endothermic animals, such as humans and bears, what we're able to do is we're able to generate our own body heat using our cellular metabolism. So we're able to control our own body temperature, not by using tricks from the outside environment, but rather by controlling what's going on within our own self. Now, there are other things that need to happen in order to maintain homeostasis, and we're going to talk about these in the two separate videos. Osmoregulation is controlling how much water and then whatever solutes are dissolved in that water. That's osmoregulation. Excretion is how we get rid of any metabolic waste or any waste that we make on our body as a result of doing those metabolic reactions. So, for example, an excretion that would happen or a metabolic waste that would happen is the production of urea, and we'll look at that as we get to the third and final video. So let's focus on thermoregulation in this video. So heat can be lost or gained in 4 different ways. There's conduction, convection, radiation, and then evaporation. And so we're going to focus on each of these 4. You guys are probably very familiar with evaporation, which is sweating. You might have heard of convection as in a convection oven. And then you know that microwaves produce radiation, and so we can think of microwaves as being a radiant heat. Now, to define each of the 4 types, conduction is simply where heat transfers from one molecule to another because they're in direct contact. So if you put a pot on top of the flame on your stove, the fire is giving the heat directly to the pot. The pot is giving the heat from the flame directly to the water that's inside of it, that's touching it. That is conduction. Whereas convection is how we actually transfer heat by simply having air move past a surface. So when hot air blows on you and that warms you up, that's convection. Radiation, on the other hand, is the electromagnetic waves that happen, and that electromagnetic waves produce radiation that then allows heat to be transferred from one. There is no direct contact required for radiation. And then evaporation is where we lose heat from a surface by using the liquid that's there. So sweating, right? We produce the liquid sweat, and that allows us to lose heat when the air blows over our body. Now, thermoregulation involves adaptations that have developed over time in the organism that allows us to figure out how do we gain heat, how do we lose heat, depending on what the environment is. Endothermic animals and many of the ectothermic animals are able to maintain a pretty steady internal temperature, even though the outside environment is fluctuating. So we might always assume that if it's 20 degrees outside, a lizard would also be 20 degrees. But they have learned adaptations that allow them to control that body temperature much better than you would assume for an ectothermic animal. Whereas we as humans are endothermic, and we are able to maintain a fairly constant internal temperature regardless of whether or not we're in the snow or the desert on a hot summer day. One of the things that happens is we can produce heat even in cold weather by simply increasing the amount of metabolism we're doing, the amount of chemical reactions happening in our body. And how does that happen? Well, in cold weather, our hormone, our endocrine system, actually will tell us to increase our metabolic rate, so to do more chemical reactions, so then we generate heat production. Cell respiration generates heat. One of the things that can happen for like a honeybee, how do they survive in cold winters? Well, what they do is they cluster together in these big hive groups, and then when they're shivering or they're clustering and they're kind of moving around, they're generating heat and warmth, and it actually allows honeybees to survive during very, very cold winters. Another way that we could maintain thermoregulation is because we have insulation, right? If you have hair on your body, if you have feathers on your body, or you have a lot of fat, you're able to, again, maintain. And it turns out that most mammals and birds rely upon hair, feathers. We don't have feathers. Humans don't have feathers, but we have hair and we have fat. And that's our major contributions to helping maintain the thermoregulation. The birds have their feathers and they have fat as a way of maintaining or having their homeostasis temperatures reached. Another thing that we have is we can have circulatory adaptations. So we can actually determine how much heat is gained or lost by simply changing the amount of blood flowing to our skin. So if you're really hot, what you'll notice is that your face is often flushed. And the reason why that flush appears is because all of your blood vessels have dilated, they've moved closer to your skin, so they're visible as a way of trying to help cool off the blood inside of your body that it happens because you're hot. If you're cold, one of the things that happens is your blood vessels will constrict, so they'll get really small as a way of keeping all the blood closer to our vital organs like our heart. One of the cool things that some animals do is they do something called a counter-current heat exchange. And their blood vessels are designed to have warm and cold blood, literally temperature, warm and cold blood, flow in opposite directions as a way of forcing diffusion or of heat to occur. So if you look here at our goose, what we have is blood from our body core. And here it is, and you'll notice the temperature is it's warm. What's happening is that as the blood goes out to our extremities, it gets colder before it returns to the core. So what happens is by having the artery next to the vein, what allows is the warm blood will be in very close contact with the cold blood, therefore will be transferring that heat across. And so what we find is that it's a way of kind of regulating or maintaining the body temperature, the blood temperature in that core region. The same thing happens with dolphins, but what they do, if you notice, is it's the exact same methodology, but it's just a lot more complex. One of the other things that happens is, I've already talked about this, is that kind of cooling off through evaporation. This is known as evaporative cooling. It's sweating or panting if you're a dog or a pig, and that's how you maintain your body temp. There are other things that you can do, and these are behavioral things. So when you are, whether you're an endotherm or an ectotherm, what happens is you can actually go, okay, I'm really hot, I think I'll go stand in the shade of a tree. If you're an ectothermic animal and it's cold on the morning, you go find a hot rock that's been sitting in the sun. When temperatures drop in deserts, you'll often find that snakes will go out into the top of the sand or onto rocks or to the pavement roads. And that's because there's warmth stored in that rock or material from the day, and they'll use that as a way of maintaining a correct body temperature. Sometimes animals will simply just migrate out of the area. You know, great migrations when the snow comes. And then you can also just take a bath. So if you're a pig and you're hot, you go roll in the mud. One of the things that happens is a process that's called torpor. And what torpor is basically, it's a type of hibernation that happens when it's cold, or it's an inactive state. So there's hibernation as we think of with a bear, but then there's also something called torpor, and torpor does not necessarily have to be only hibernation. And simply what happens is that when it's cold, the animal will simply become as inactive as possible. Everything will shut down as much as possible, yet still maintain life. And by doing that, by lowering the metabolic rate, you're saving energy. You are allowing the body temperature to decrease greatly, and then that can actually allow you to survive kind of extremely cold environments. There is a type of torpor, which is long-term. That's your hibernation of bears. And then there's something that also can happen in the warmth of the summer, and it's called the estivation. So estivation is a type of torpor. Basically, what happens is when it's really, really hot out, it's too hot for kind of moving around, what animals will do is they'll slow their metabolism down. They'll become as inactive as possible. And that way they can survive when it's really, really low water. And so estivation is another one of those tricks of the trade that animals will use to maintain the correct body temperature. That's the end of our video for now.